Hello, and welcome to the next part of the Embedded Linux for Zynq 7000 and Zynq Ultrascale Plus lesson, where I'm going to share my knowledge about system software and application development. Just to remind you, in previous lesson we considered just introduction, we considered what is system software for Linux image and what is application development for Zynq 7000 and Zynq Ultrascale Plus. In this video I'm going to show you how to deal with system software for Linux image. Just to remind you, system software for Linux image, it's a set of files that are listed here. And today I'm going to teach you how to get FSBL, first stage bootloader, PMU and ARM trusted firmware, bitstream, device tree, and how to configure U-boot or second bootloader. In next part we will consider how to deal with build root for getting Linux kernel, file system, and how we can add our device tree. For today's video I will consider just Zynq Ultrascale Plus, but of course all information could be applied to Zynq 7000 as well. So here I listed all steps required for dealing with system software. So first of all we have to create hardware design in Vivada and export the hardware design to Xilinx SDK. Here I created very simple hardware design. It's just Zynq Ultrascale Plus and XCDMA with connected both stream channels and interrupts connected to Zynq processing system. Actually, you shouldn't care about XCDMA. I just took this IP core for example. So I have compiled hardware design, and first of all I have to make an export hardware and launch SDK. So I have opened Xilinx SDK with hardware design file. And before I begin, I just will show you Xilinx Wiki. It's a Xilinx Wiki, it's a Xilinx open source Linux. Actually, all information I took from this wiki, and I just will show you design flow from Xilinx. So design flow from Xilinx says that you need Vivada for getting bitstream and for getting a hardware description file. So I will do the same. Then you need Xilinx SDK for dealing with system software like FSBL, like device tree, and like PMU firmware. I will show you how to get all these three files. Then I will show you how to fetch sources like U-boot and like ARM trusted firmware, and how to compile all these files by using cross compiler. I will show you how to create by using Xilinx SDK boot bin. It's a boot image for our target platform, and finally I will run boot bin file on my Zynq Ultrascale Plus board. In next part of the lesson I will show you how to get Linux and rootfs file system by using build root, and I will explain actually why I prefer to use build root, not for example Peta Linux or not open sources. Okay, so firstly go to the page about sources, where we can find sources. I will show you what kind of sources we need and how to deal with all the sources. Actually, all steps for building Xilinx image you can find here, but I will use the same steps but slightly different from Xilinx Wiki. So you can use as you want actually. Yeah. So what sources we need? Of course, it's a GitHub from Zynq, it's a bootloader. Then we need device tree generator plugin for Zynq SDK, device tree compiler that is required to boot U-boot, and ARM trusted firmware. Also, I need a cross compiler. So I downloaded toolchain from Cortex ARM Cortex-A family, the latest version, and I will use my cross compiler on Linux hosted operation system. So I have a virtual machine with boot installed. So for Zynq 7000 we will need Arch 32 target with hard flat, and for Zynq Ultrascale Plus we will need Arch 64. Yeah, this is the one. Arch 64 for Linux target cross compiler. So about fetch sources. You just can so I have a virtual machine with already fetched sources. So this is the cross compiler. This is my virtual machine with boot installed. This is a device tree compiler, and this is an ARM trusted firmware, and you boot Xilinx GitHub as well. So this is a folder for device tree. Later I will show you how to use and why I need to use this folder. I directly downloaded all these sources from Xilinx GitHub and on my virtual machine, but device tree generator, as I'm using Xilinx SDK on Windows, so it means that I need device tree generator, and I just want you to pay attention that we have to load a version of device tree that is equal to the same to our Xilinx SDK. So I am using Xilinx SDK 2019.1, so I will just load this part, and I will save this part to and I will save this repository to folder where I have Xilinx tool installed. So I have Xilinx SDK, open it, and the first step what I need, it's just point where is my device tree generator repository. So here I just add path to my device tree generator. Okay, first I will start from device tree. For getting device tree, I just need to use Xilinx board support package project. Okay, so so I have to wait for a while. Okay, so I have compiled device tree. So actually it's a set of files, like for example PL.tce. It's a file, it's information about all our memory mapped device in our programmable logic. In my programmable logic I have XCDMA, so you can see here XCDMA address, both channels, memory map to stream and stream to memory map channels. So next step, I just will copy all these files to my device tree folder on my virtual machine. Okay, just let me extend this one. And here in my device tree folder I have built a script. I just will show you. You can find the script on Xilinx wiki. Again, I just will show you. It's a build step device tree blob. Actually, why we need this script? We need the script because we will compile all these files together to one common file that we are going to use in our U-boot and later for our Linux kernel. This file will be named as a custom DTS file. Okay, so just let's run our script. Okay, so here we have our custom DTS file. I just will copy this file. So next step, I will compile ARM trusted firmware. So just open terminal, and I just want to remind you that I have to use cross compiler here. So I just will export cross compiler, which is situated in my GSS RH64 folder, and export architecture. Okay. For compiling ARM trusted firmware, I have to run the command. Okay, so just let me check. It should be in build folder, Zynq compare release BL31. Yeah, this is the IL file that we will need. So I just will copy this file, and I will put this file here. Okay. So next, it's our U-boot Xilinx. It's our U-boot Xilinx. But before we will deal with our U-boot, we will create FSBL and PMU firmware. Okay. So for FSBL, we just will create new application. This FSBL standalone. Okay, and Zynq compare FSBL. Okay, just run it. Okay, so here we have executable FSBL file, and one more file. We need PMU firmware. Just firmware file. For compiling this file, I will use I will choose processor like PMU, and just finish and just run it. Okay, so we have executable PMU file, and so what we need, we just will copy. Okay, let's copy both of these files to our virtual machine. And okay, so here we have custom DTS. It's our DTS. It's our device tree file. So it's a file with information about all our memory mapped devices in our processing system and in our programmable logic. We have first step bootloader executable file. We have ARM trusted firmware, and we have PMU firmware. Bitstream we can find from generated we can find here, I guess. So yeah, this is our bitstream. I just will put here, and I just will rename in system bit. And okay, just what we need. So we have FSBL file, we have bit file, and we have ARM trusted firmware, and yeah, just we need a U-boot file. Yeah, okay, so U-boot, it's a second bootloader. For our second bootloader, we have to make some configurations. So first of all, we will use custom DTS file that we already have here, and I will use custom header file. This is a file where I have settings for my Ethernet. What is kind of settings? It's just server IP settings. In case if I'm going to load my Linux image, or if I'm going to load any image by using Ethernet. And here I define config extra environment settings. What is settings like? For example, my IP address, it's an IP address of my target, and it's a cd boot variable. This is a kind of variable that will be loaded in auto boot mode. So in auto boot mode we will see this message, and then our second bootloader will try to load. Okay, we'll try to load Linux image from QSPI flash, starting from 0 address, that's amount of bytes, to RAM memory, and then we will boot our image starting from this address in our RAM memory. So before I start compile my boot executable file, I have to put both of these files in the boot Zynq GitHub folder. So I need put custom DTS file in the U-boot arch ARM DTS folder. Okay, and I have to add make file in the folder. Okay, here is make file. So here I can find all device tree files, binary device tree files for all boards listed in Zynq GitHub for U-boot, and I just will add my custom. Okay, here custom point DTB. Please pay attention that I point binary file, not DTS, but DTB file. Okay, that's it, and our custom header file we will put in the include folder configs. Okay, just copy. Okay, that's it. So what we need? We need to edit U-boot configuration file. For U-boot configuration file, we will use Zynq mp-virt config. Actually, this configuration file could be used for any Zynq Ultrascale Plus board. So I just will add. I just have to add config default device tree. I will point our custom. Okay, and here config of list I will add our custom as well, and I have to add information about our custom header file. Okay, so I just will put this information about our custom. Okay, so that's it. Okay, so we just okay, so first of all, what we need: export cross compile, arch, then we will make Xilinx Zynq dev config, and we have to export our device 3. Okay, so export device 3 custom. Okay, so it means that we are ready for compiling our U-boot executable file. Okay, just run it. So it took a couple of minutes to compile second bootloader, and the file we are interested in, it's a U-boot executable file. So we can find here in our in this folder. I just will copy and paste to other files. Okay, so we are ready for creation boot image for our target. So what we have ARM trusted firmware, we have PMU firmware, we have first stage bootloader, we have second stage bootloader, and we have bit stream. So I just will copy all these files to my Windows. Okay, just let's copy paste. Okay, and the system bit. Okay, and so here I have a custom beef file. What is the file? It's a file. It's just instruction for creation RAM image. I will use this custom beef file in my Xilinx SDK. So next step, it's just open Xilinx SDK and create boot image. For creation boot image, I will import existing beef file. It's my custom file. Okay, so it has my first step bootloader, it has my PMU firmware, system bit, ARM trusted firmware, and second bootloader. Okay, so just create, and it will create boot bin file. Okay, so okay, let's see. Yeah, so okay, we have our boot image that we are going to load into QSPI flash on our Zynq Ultrascale Plus target. So I have Zynq Ultrascale Plus target connected to my computer, so I just need to program flash memory. I will point to my boot bin file, and I will point to my fsbl ilf file. Okay, so just program it. Okay, so it took a couple of minutes, several minutes, and yes, so we are ready. So let's launch terminal. So I just will launch a terminal. Okay, so okay, right now our second bootloader is trying to load image, but of course it's impossible because we don't have Linux image in our QSPI flash. How to get kernel image, as I said to you before, I will teach you in our next lesson. So let's analyze all information we have here in terminal. So first of all, it's our message that we should use, that we should get from our second bootloader. It's in auto boot mode, and here we see that our second bootloader is trying to load Linux image from QSPI and boot it, but of course it's impossible. So let's see print environment. Let's run print environment command. Okay, so in print environment, what we can see is our word, our boot command. It's cd boot command. Here is our IP address and address for our TFTP server. Here is our meaning of cd boot variable, and and command that we are going to run in auto boot mode. I will show you how to load any image by using Ethernet. So right now my Zynq Ultrascale Plus board is connected by using not only COM port but Ethernet as well. So it means that I can make ping 0.21. Okay, yeah, and I have TFTP. Let's run it. TFTP. So this application. Sorry, I have already run it. Yeah. So this application is this application points to board where my boot bin image is situated. So if I just want to load my boot bin file into RAM memory, I just will use this command. Address is 6000. Okay, and my file, it's boot bin. Okay, just run it. Okay, so so what does it mean? It means that in my RAM memory I have boot bin file. So as you can see, it's much faster than for example, if I want to load this boot bin into my QSPI flash, I have to use this kind of commands. Erase. Erase. Start from 0. So it means that I want to erase my QSPI flash starting from 0 pointer, and this is the amount of bytes. Okay, it takes a little bit time, and okay, so as we remember, we have boot bin file in our RAM memory starting from this address. So just will write to QSPI flash all this file. Start address, and okay, so and amount of bytes. Okay, that's it. Okay, just start this command. Okay, so it's as you can see, it's much faster than if we use program flash memory via Zynq SDK. Yeah. So just run again. Yeah. Yeah. Okay, so it's run. Okay. Okay, so let's summarize all information from today's video. So for getting boot image for our target without kernel Linux, so it means that boot image up to second bootloader, we have to make two set of steps. For first set, we have to use Xilinx SDK and Vivada. For second, we have to use ARM cross compiler. So in Xilinx SDK in Vivada, we have to create hardware design and export the design to Xilinx SDK. So it allows us to get bitstream and to export hardware design file. Then by using device tree generator plugin for Xilinx SDK, we will get our device tree file, and we can then compile FSBL and the PMU firmware files. So again, all these files we can get by using just Vivada and Xilinx SDK. In the second set of steps, we have to use ARM cross compiler for compiling ARM trusted firmware and U-boot sources that we can fetch from Xilinx official GitHub. Also, we are able to edit settings for our second bootloader in case, for example, if we are going to load our kernel image from different sources, like for example microSD, like QSPI or via Ethernet. For doing this, we just have to add our DTS file that we get from Xilinx SDK, and we have to prepare our header file with settings where we can point the source device from which we are going to load our kernel image. And finally, we will use Xilinx SDK for creation boot our boot image. Okay, so if you have any questions, so don't hesitate, feel free to ask. I will try to answer.